Hello everyone, welcome back to another GIS statistics lecture video. And in this lecture video, I want to begin our discussion on model and variable selection. Right, so up to this point, we've kind of covered variable selection a little bit, and we've talked about a bunch of different models. But let's say that you're going to start from scratch, where you have a question in mind and you go out, you find some data, and you want to make a model out of that. Well, how do you decide, what variables to use and what type of model, again, constrained to the ones that we've learned about? How do you go about making those choices? And so what I want to do in this video is sort of outline broadly the steps that I would go through to go through this process. So the first thing we're going to do is variable selection. Right. So how do we know what variables we want to keep? So there's going to be 4 steps to this, and we're actually not going to talk about the first one other than right now. And the first idea to variable selection is think about relationships. Right. And in this case, I'm not talking about graphing anything. I'm not talking about looking at correlation coefficients or anything like that. I'm talking about in theory. Right. How do we go about in theory coming up with these relationships? Do these relationships even conceptually make sense? Right, and this could be something where you're testing that, right? You think that, hey, maybe there's a relationship between the amount of food someone eats and their weight, right? You might think there's a relationship there, right? Now, a good sort of a nonsensical example highlighting the importance of thinking, right, is you wouldn't, for example, it would make no sense at all to try to create a model where you're modeling somebody's height based on the number of times they've been fishing, right? That doesn't even make sense in at all. So that's sort of the first hurdle, right? It just doesn't even make sense to include this variable at all, right? So the second step, once you think there's a relationship there, right? The second step is going to be to actually examine the relationships. Right? And I'm not talking about putting them in a model yet. I'm talking in this particular case about looking at things like scatter plots, and correlations. Right? So at this point, right, we've made a case that, hey, we think there's a relationship in theory. Now we're going to look at the relationships, using all the different methods that we've talked about. Does there appear to be a relationship? Does that relationship seem significant? Right, that's step 2. And this could include things like transforming them to make them linear, right? So this could include, right? This could include transformations, right, which we haven't really talked about too much, but this could include transformations. So let's say you go through the process of picking variables you think make sense, proving that, hey, they actually seem like they make sense. Right, this third step is going to be where you actually generate models. Right, and this is going to be where we're going to spend a little bit of time in this video, in this module, really talking about how do we compare them, right? So you're looking for things like the coefficients and the p-values, right? Are the coefficients, are they important, right? If on an absolute scale, right, if the influence they have isn't meaningful, right, if it's zero, right, you're not actually adding anything. If the p-values are strongly insignificant, right, that might be an indication that maybe we were wrong here. We're going to talk about this concept called dredging, which is basically the idea that we're going to take whatever variables we throw in, and we're going to look at every possible model that we can to find the optimal model. And we're going to talk about this thing called AIC, which is the A-key information criteria, which we'll talk about how this allows us to compare models. And then, so once we've figured out, okay, what variables do we need to keep, then we need to go into this idea of model selection. Right, so dredging is going to tell us, dredging, AIC, coefficients, and p-values, right? These are going to tell us what models we want to keep, what variables we want to keep. This is going to be in an OLS framework. Right, but now what we want to do is say, okay, well, we have an OLS model, right? We have the best OLS model that we're going to get based on these criteria that we're going to talk about. But the question, again, because we're in a spatial framework, right, is can we do better with one of the spatial models, right? The spatially lagged X, the spatially lagged Y, or the error model. And we're going to say, okay, well, how do we make that distinction, right? How do we choose if, and which spatial model do we use? Right, and again, we kind of already talked about this a little bit in the previous couple sections. But what I want to do here is I want to explicitly talk about, examining the lagged means. Right, examining lagged means and Moran's eyes. Right, the stuff that we spent so much time talking about in the previous module, right? This can inform this decision. And then finally, the last thing that I want to talk about is this idea, and we kind of talked about it in one of the videos briefly, but I want to explain it more, is this idea of the Lagrange multiplier. Right, the Lagrange multiplier is basically a statistical test to confirm whether or not, we have the lag means or Moran's eye for the Y's, the X's, or the residuals. Right. So again, examining lag means and Moran's eye of the dependent, independent, and residuals will kind of give us an idea of whether we should use lagged Y, lagged X, or spatial error. But this Lagrange multiplier, right, kind of like this AIC and dredging, is going to be sort of a statistical approach to figuring out whether or not we're right. So hopefully this makes sense. Again, a lot of this is going to be review. We're just going to be wrapping everything together with a nice bow to sort of be able to have a workflow for determining, what variables do we use and what model do we use, and being able to support that with statistics. So hopefully this makes sense. And if you have any questions, please reach out. Thank you.